Okay, here we are, and we're going to do the second video on Lewis structures, and I'll just showing you the little pyramid there, the Great Pyramid. So this would be the second video, and we're going to do polyatomic ions and those with charges. Let me turn on the light here and maybe get a little bit better view here. Now the first one we'll do. Now you guys remember when we did the Bohr models and dot diagrams and electron configurations? When we did the dot diagrams, those are really Lewis structures, Lewis dot diagrams. So if you remember, now go ahead and get out your periodic table, if you don't mind. That would be a good thing to have. While I zoom in a little bit. Okay, and we know that sodium's in group 1 and has one valence electron. So basically, we remember that when we drew the dot diagram, or Lewis dot diagram of sodium, we did this, and the dot could go on top, or it could go on the side and such. And for example, we know that calcium, which is in group 2, would have 2, and you can put them like this, or you can put them both on top or both on the side. And of course chlorine in group 17, so it has 7 valence electrons. So right, left, up and down, then go all. And let's try to make these dots a little bit better. Should really get a pen with more ink, I think. But anyway, this is the Lewis dot diagram or Lewis structure for chlorine here. It's got 7 electrons. Now, it's got one space left and it wants to have another electron really bad. Now, if they have charges, so let's say that chlorine has already gotten that 1 electron and it's negative. Well, so we look at this and it's got 8 electrons. It's got the 7 from being in group 17 plus 1 more. So, of course, you're going to put, it's a -1 charge. You put negative or -1 or 1 minus. Any of those will be okay with me. So, so we can add electrons or we can subtract electrons. And if we have something like O2, I'm sorry, not that, O minus 2, we know we got 6 electrons from being in group 16, and we get 2 more because it's minus 2, so we have 8. So again, we're going to put our oxygen there and put in our 8 electrons. And we know that oxygen is now happy. It's a -2 charge, like that. Now, if we were to have a polyatomic ion, such as sulfate, SO4 minus 2, how would we make that Lewis structure? Well, we're going to do what we did in the first video. We'll say S is equal to, and we know that's in group 16, so we got 6 valence electrons times 1 atom, because there's no subscript there. It's equal to 6. Oxygen is in also group 16, so it's got 6, but it has 4 of atoms in here in SO4, so times 4 is equal to 24. And we got 2 minus, which means it's gained 2 electrons. So we're going to add 2 here. If it were plus 1 or plus 2 or plus 3, we would be subtracting electrons. So anyway, you add these up. This is 30 plus 2 is going to be 32 electrons. Now, when we draw these polyatomic ions, if you get 1 atom of one kind and 4 of another, almost always that one kind is going to go in the middle. So you're going to place your atoms. So we got sulfur surrounded by 4 oxygens here. And we know the octet rules that we want to give them all 8 electrons and hope that it works out. So what we're doing is we'll put sulfur is going to get its 8 electrons, and we can give every oxygen 8. Now remember, they are sharing electrons. This shows how they're sharing electrons. You get 4 single bonds here between sulfur and the 4 oxygen atoms. So we'll put our dots there, and really should be a little bit closer, like that, I suppose. And now we've got to add them up to see if we did right. So we got 2, 4, 6, 8, and I'm just going to circle this to help me. And we got 2, 4, 6, 8. I'm going to circle that, but you don't circle these when you're doing your finished product. And we've got 8 here, and we got 8 there. 8 times 4 is 32. We got 32 electrons, and how convenient that is the same. So we like that. So now we're going to put this in its final form, so make it easier on the eyes, your chemical formula. So we got sulfur with a single bond to oxygen all the way around, like that. And now we've got to show our unshared pairs of electrons. Let me move this camera just a bit. So every atom, now one line means 2 electrons, the 2 dots, but this is just where it's easier to see the bonds. Okay, and now we're going to, because it's a polyatomic ion and it's a charge, and there's a charge involved, and they're all sharing the charge. So we've got to put a big bracket around this thing and put 2 minus up there. We're going to separate that. Okay, so it's minus 2. So that's how you would draw the Lewis structure for a polyatomic ion which has a charge. We can do another simpler one with hydroxide, and we're going to write this out again. So oxygen is equal to 6 times 1 is equal to 6. Hydrogen is equal to 1 times 1, which is equal to 1. Let me turn that off here. Don't need interruptions here. Okay, so we add this up, and we have a negative charge here. That's a -1. So we're going to add 1 more because we gained a negative electron. We gained an electron. So it's going to be 8 electrons. So again, we're going to place our atoms side by side. It's the only way to do it. The only way you can do this. And we know that hydrogen wants 2 electrons. And the big O wants 8. And so now oxygen is happy, hydrogen is happy. 2, 4, 6, 8, got 8 electrons, and voila, it worked out again. But I'm telling you, one time it's not going to work out. Okay. One of the atoms that I want to show you, let's take BF3, boron. Okay, it won't make 4 bonds all the way around naturally. Let's add up these electrons and see what they come to. Boron is going to be equal to, and that's the 3rd element, so we're going to have 3 times 1 is equal to 3. And then we've got fluorine, 7 valence electrons times 3 is equal to 21. That makes 24 electrons. So, which element are we going to put in the very middle here? Ah, yes, boron. So we put B right there, followed by 3 fluorines, and it doesn't matter which way, on which side you put the fluorines. So we can put in 24 electrons. So boron is not going to have 8 electrons here. It's only going to have 6 because of its electron configuration. Let's do this. two dots over here. So this way, this 4 has 8, this one's got 8, this one's got 8. 8 times 3 is 24. So boron does not need to have this last pair of electrons over here. Can't hold it. So anyway, that's the same. So do our final format here. Okay. So let's see here. We've got B, F, 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 and put in our electron configurations. Okay, see how that goes. I think my recording has stopped on me. Or maybe it hasn't. So anyway, that's it for BF3. I'm sorry. Okay, there we go now. Alright, we're going to stop this video and then we're going to come back with double and triple bonds.